Hi guys, Miss Scott here. So we're going to jump into chapter 8 today. Before we do, here's your bad joke. Why are the oceans blue? Well, this is kind of a sad one. It's because the coasts never wave back. Oh. Alright, so chapter 8 is all about quadrilaterals. So you can see we're going to cover the first 3 sections here, take a quiz on that, cover the last 3 sections, and then test on chapter 8 at the end of section 8.6. So some of the big ideas we're going to cover is using angle relationships in polygons, using properties of parallelograms, and then classifying quadrilaterals by their properties. Alright, so let's jump into section 8.1, which is find angle measures in polygons. So our essential question is, how do you find a missing angle measure in a convex polygon? And we're going to talk a little bit about this. Convex actually just means that all of the angles go outward. There's nothing that caves in. And we did talk about this earlier this year, way back in chapter 1, we talked about convex and concave polygons. Alright, so our first theorem in this chapter is theorem 8.1, which is the polygon interior angles theorem. And that theorem just tells you that the sum of the measures of the interior angles of a convex polygon with an n number of sides, you just take 180 and then multiply it by n minus 2. Alright, so let's just use that formula to practice a little bit here to see how many degrees all of the angles inside of these two figures would have. So a 14gon has, of course, 14 sides. So what we're going to do is just plug into this formula 180, and then we do n minus 2, so in this case 14 minus 2, or 180 times 12, which is 2,160 degrees. So if you added up all 14 angles in a 14gon, as long as it's convex, it will add up to that many degrees. Alright, let's try another one here. So on number 2, notice we have 4 sides in this quadrilateral. So we are going to use that same formula, 180, and then times n minus 2. So in this case, 4 minus 2 is 2. So 180 times 2 gives us 360 degrees. And that is going to lead us to our second theorem. So this is actually a corollary to theorem 8.1, so it's something that we can use 8.1 to justify this. And that's just what we saw in example 2. So if you have the sum of the measures of any quadrilateral, not just the one in example 2, is always 360 degrees. So if you have a quadrilateral, you can just use this. It's going to add up to 360. All right. Now in the next example, we're going to go backwards. They tell us that the interior angle sum of some polygon is 900 degrees. So let's set that equal to 180 times n minus 2, and then we're going to solve this for n. So the first thing I'm going to do is divide both sides by 180 so that these will go away. And then 900 divided by 180 is 5, so that's going to equal n minus 2. And if we add 2 over to the other side, we get these to cancel, and we see that 7 is n. And if you recall, they want us to classify the polygon. So a 7-sided polygon is called a heptagon. So that is what this would end up being. All right. And now notice in example 4, we have 1, 2, 3, 4, 5, 6, 7 angles. So it has 7 sides. This here is a heptagon. So we know that the angles add up to 900 degrees. So what we're going to do is take all 7 angles and set them equal to 900. So I'm going to say 900 is equal to, starting down here with x, plus 2x, plus 156, plus 133, plus 99, plus 145, plus 112. So I just add all 7 angles up. And then we can combine like terms. So actually we have 900 equals 3x. And then if you add all of these constants, you'll get 645. All right, now let's solve this. So we'll subtract 645 from both sides. These here will cancel. And 900 minus 645 is 255 is equal to 3x. And then we can go ahead and divide by 3. So we end up with x being 85. Okay, all right. Got one more theorem for you here on this page, so let's take a look at it. Theorem 8.2 actually tells you the exterior angles of any convex polygon is always 360 degrees. So it actually doesn't matter how many sides the polygon has, those exterior angles are always going to add up to 360. Let's use that in example 5 here. So notice we have all of these angles. They are outside of the polygon, so that's why we call them exterior angles. So we can take all of these 6 angles and add them up to 360. So we'll say 2x plus 59 plus 54 plus x plus 80 plus 59. All of the exterior angles equal 360. All right, we have some like terms here, so if we combine 2x and x, that's 3x. And if you add these 4 constants together, you'll get 252 is equal to 360. So let's go ahead and subtract 252 from both sides. All right, these will cancel, and then we end up with 3x is equal to 108. So let's go ahead and divide by 3, and we'll get our answer of 36 would be x. Alrighty, so always use 360 if you have exterior angles. Alright, in our next example, we're going to talk about the interior angle measure sum and the exterior angle measure sum. So you just have to read the question carefully to figure out what to do here. And just these are the formulas that were on the other page. I just put them on the top here so you don't have to flip back and forth. Alright, well it says to find the measure of an interior angle and an exterior angle of a regular heptagon. So a heptagon, I don't know why we're using this so much in this section, but that's okay, has 7 sides. So to find just one interior angle, if it's regular, that means all sides and angles are equal. So all sides and angles are equal. All right. So here's actually a couple of theorems that you can use. If you're going to have an interior angle, which I'm just going to say IA, you take the sum of those, which remember is n minus 2 times 180, and you divide it by the number of sides, because that's going to give you how many degrees each angle is. If you're trying to do an exterior angle, again in a regular polygon, you do the same thing, but we know they always add up to 360, and then we can just divide by the number of sides. So if they want you just to find one interior angle, we have to use the fact that we need to divide it by the number of sides. So let's plug into that formula 7 minus 2 times 180, and then we'll divide by the number of sides so that those angle degrees are divided equally among those 7 angles. All right, so this is going to be 5 times 180 divided by 7, or 900 divided by 7, which is about 128.6 degrees. So each angle, just one angle would be that many degrees, not the whole angle sum. All right, and then for one exterior angle, we're going to take 360 and divide it by the number of sides, which again is n, so So this is to find an exterior angle. And that ends up being 51.4. So one exterior angle would be that many degrees. And you should notice that if we take 128.6 plus 51.4, those actually add up to 180 degrees, which always should be the case. So that's a good way to check really quick. All right. Now in 7, they actually give us what each exterior angle is, and we're going to use that information to find n. So again, if you use that formula up above, the interior angle is equal to 108. So we're going to plug in 108 as the interior angle is equal to n minus 2 times 180 over n. And to solve this one, since there's a variable in the numerator and the denominator here, I'm going to put this 108 over 1 and cross multiply. So over here we end up with n minus 2 times 180 is equal to 108n. Okay, and now we're trying to solve this for n. So first thing we should do is distribute that 108 or 180. So we have 180n minus 360 is equal to 108n. Let's get our n's all to one side. So we'll do that by subtracting here. So these cancel, and we end up with negative 360 equals negative 72n. And then we can divide by negative 72. So these will cancel, and we end up with 5 is equal to n. So if that's the case, this would be a pentagon. All right, and it would be a regular pentagon just because we're using that rule that all the angles are equal. All right. Okay, now let's see if we know each exterior angle is 10 degrees. So this one's a little bit easier because remember the exterior angles are just 360 divided by n, and they told us that that answer is 10. So again, I'm going to put that 10 over 1. We can cross multiply here then, so 10 times n is 10n. 1 times 360 is 360. And then let's go ahead and divide both sides by 10, and we'll get 36 for n. And there's no special name for a polygon with 36 sides. We just call it a 36gon. All right, anything with more than 12 sides, you just write the number and then hyphen gon, just FYI. Okay, let's look at our last example. So this one's going to be the trickiest here. The measures of the interior angles of a convex pentagon are 3x, 4x, 5x, 7x, and 8x. Find the largest exterior angle measure. Well, in order to do that, first we're going to need to figure out what x is. So we know this is a pentagon, so to figure out what those 5 angles have to add up to, we're going to use 180 times n minus 2. So in this case, that would be 180 times 3, which is 540 degrees. All right, so now let's take those 5 angles, 3x, 4x, 5x, 7x, and 8x, add them all up, and we need to get 540 degrees. So all together, this is 27x equals 540, and we can go ahead and divide by 27, and we end up with x equals 20. Now notice these are all interior angles, boop, 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 boop. We want to find the largest exterior angle. So I would recommend jotting this down in your notes. It turns out that the largest exterior angle matches up with or goes with the smallest interior angle. Okay, so that's If it's got the biggest exterior angle, it's going to be the smallest interior angle. And we need to use that fact because we only know the interior angles. So first, let's find the smallest interior angle. And if you notice here, that's going to be the 3 times x. Well, we just found x was 20. So that's going to be 60 degrees. So if that's the smallest interior angle, the largest exterior angle we're going to find by taking 180. So remember, these two always add up to 180 degrees. And then if we subtract that interior angle, that tells us the largest exterior angle will be 120 degrees. So quite a few steps in that last example, but that is how you solve it. All right. So thank you guys for watching. If you've got questions, come find me. I will help you, or feel free to leave any comments or questions down below. All right. Thanks, guys. We'll see you next time.